Hello everybody, I'm Nick, and today I'm going to show you how you can use source generators, a feature added in C# 9, in order to write code that writes code. And we're going to take a look at the possibilities that such a feature opens up for our projects. Now, source generators is a type of metaprogramming, similar to how reflection is a type of metaprogramming, but reflection is runtime, while source generators will actually, during compilation, give us the possibility to observe our code and add to that by adding source files. It cannot modify existing code, but it can actually add on top of it. And you'll see just with the two examples I'm going to show you here that the potential is limitless. If you like that type of content and you want to see more, make sure you're subscribing and the notification bell to get alerted when I upload a new video. So let's go straight into the code. And what do I have here? I'm so excited for this. So here I have a regular program.cs, what you would get if you create an API. Nothing fancy. And here I have a startup, which is also like nothing fancy. The only thing that is different is, actually nothing is different. I just left it as it is. So no fancy registration, no nothing up my sleeves. And what I'm going to do here is I'm just going to create a class. And I'm going to call this getCurrentTimeHandler, right? Just a class. And the only thing I'm going to do is I'm going to create a public dateTime method, right? I'm going to say getCurrent time here, or UTC, because it will return actually UTC, and I'm just going to return datetime.utc now. And the other thing I'm going to do is I'm going to add a header. It's going to be an HTTP get, and here I'm just going to say time 1, right? And I'm going to just run this code. No controllers, no nothing, right? Absolutely nothing. I'm just going to run the code. And what I get back is the Swagger launch page, which comes with the default registration. And if I say try now and execute, you see that I get this back as if it was a proper endpoint in a controller. This is possible because of source generation. This ability to just quickly go ahead and prototype, like I could even, if I didn't want to have the datetime now, and I had something like a datetime provider, in order to make the datetime mockable, or you could use system clock as well. But if I wanted to do that and have proper injection, let me quickly just do that and then put it in providers folder. And if I go to the handler now, I should be able to say private read only datetime provider. Here we go, and I inject that, and then I should be able to use it here. UTC now. So we're building this, everything built, running, and now injection should also be working. So if I try this, I'm getting the datetime back, and this is coming from the code that you just saw. So with all that, you can see that we basically have a very fast prototyping behavior, and this could actually just work as a proper piece of code as well. And the way this happened is through this other project I have here, .gen. I'm going to show you what this has. It actually has a controller generator, and what it does, it actually observes for this header, and then it builds a controller out of this class. And if I search for generated controllers, you can actually see the controller that it built behind the scenes for us. And this is a fully functional controller. The problem with this approach, and the reason why I'm using this as an example, is just to grab your attention to the feature. It wouldn't really be usable in that form in a realistic scenario, because you are not able to actually debug this handler because it's used to generate another controller. So you'd have to debug the controller that is generated, which you still can, by the way. At least in Rider, you can put breakpoints here and debug it. This is just one of the possibilities, right? And let's see what the source generator looks like. So if you thought reflection looks bad, yeah, this is kind of way worse. I have to say that the developer experience, at least at the moment, is kind of bad. But I know that the .NET team is actually working on improving this, so hopefully this can get way better. But you're effectively using an iSource generator interface and a generator attribute, and that's all you need to create a generator of some sort, or a source generator of some sort. And then you can basically traverse the syntax tree, because how your code is actually built or structured is actually a tree. And you can traverse that tree and search for things like contains HTTP attributes, or get the using directives and build them as a text, which is what you saw on the top of that other class, or find the classes and replace the actual class name with the controller class name, and then do some fancy things and build the actual thing and then add it into the source. And this add source is the thing that gives us the ability to have it on compile time, right? This is not something added later or something else. It is built with our project. So if the compile thing in there is messed up, the project won't compile. And that not only gives you the performance of something being compile time, but also the safety that, you know, it's working, it's there. With reflection, for example, if a method is not there, you wouldn't know unless you use an analyzer or something else that the method name that you're looking for is there, for example. So not only it's more performant, but it's also safer. Something I have to say at this point is that the debugging experience is actually pretty bad. That's the only way that I found that this works, and that's because it is on build time. So you I think you have to attach to the JIT instead of attaching to the a running process. So now with this here, if I try to build, which is when this process will kick in, and in fact I have to rebuild for this to kick in, it will ask me to attach to a debugger. And if I click on that, you will see that I now hit the breakpoint. And if I step through, I can, you know, get the syntax trees. And as you can see, it will return all the trees, and that's how it looks like. And you can see at the code in the tree, you can see at the text version, you can see the path, you can do everything, you know, lazy text here if you wanted to view your code in code, which is pretty interesting. And then the way we do this, at least in this example, is grabbing the using directives, building them as text, so the thing that goes at the top, and then getting the declaration and doing some other fancy things. I'll spare you the details because I think the details on that are a bit pointless at this stage. I want this to be an introductory video just to understand what this is about. Hey everybody, Nick from the future here. One of the things I didn't mention during the original recording was that the generator project needs to be .NET Standard 2.0, and it also needs to have those two packages, the Microsoft Code Analysis C# Workspaces and the Microsoft Code Analysis Analyzers. And something else that you need is the project that refers to that project should also have the output item type set to analyzer and the reference output assembly to false for this to work. And once you have that, this should all just magically work. What I want to do is, using that thing that we just built, right? Let me go ahead and create another folder here and say models. And in that, I'm going to create a product. And that's going to have like a GUID. So let's say an ID, then a string, and let's say name, and then a string, and then let's say description. I don't know, whatever. And now that we have this, a very common scenario is mapping, right? We've talked about mapping before, AutoMapper, Mapster, all that jazz. You can use source generators to actually build an elegant mapping solution. And I will just show you a prototype here, a very quick prototype, just to understand what I mean. So we would have this handler here. Here we go. And I'm going to create an extra one. So let me push this up. In fact, let me push this up. And I'm going to say HTTP post. Here we go. And then public action result. Yeah, whatever. Create product. And then we're going to say from body, get this product. And we just created it. And a very common thing is that we would actually, let's say return OK result. And for now, just return nothing, basically, just an empty object. And a very common thing is we would use this product and map it to a DTO of that product to store in the database, maybe do something else with. It's a very common thing because you might want to have versioning or a thinner version of the model, whatever. So instead of using AutoMapper or any of those approaches to build my objects or even the mapping code, I'm going to focus on the object building in this example, by the way. I could just use a source generator. So I would go mappable, mappable sounds good, generator. And I'm also going to create maybe a few attributes here at attributes. Here we go. So mappable attribute. Yeah, here we go. And you should implement attribute, or extend it rather. And you should be applicable to classes. Yeah, makes sense. So we can make a generator is that easy we can say generator I source generator and implement the missing members. I'm gonna stick that debugger code back in. I just copied all over the place because it's very useful. It's very hard to debug those things and just guess how they should build, which they should be built. So I use that all the time when I'm working on things like this. And now we have the context, which is where the gist of the code is. And surprisingly, the code would look very much similar to how the mapper code looks like. We're gonna get syntax trees, so they go there, and we're gonna iterate over them. So for each syntax tree, and we're gonna see whether it has a mappable attribute on top of it or not. So the example would be here. We would have something like this, right? So we wanna check all the ones that are mappable to build a DTO out of them to map to. Now the way to do this, and I'm pasting because it is a bit hard to just talk you through this because you have to try to see how it goes, but usually you have a root and then descendant nodes. It's very much a tree, and then I'm using a type declaration syntax which will detect structure record classes that might have this attached, and then I'm going to check if the attribute starts with mappable in the attribute list of that type declaration, and if it does, then I know it's something that needs to be generated. So what I'm doing then is I'm iterating over those, and I'm going to say mappable declaration here, and this is where I'm building my classes, the classes I want to map to. That's a very much similar process where we want to get the using directives. The using is those fellas up here. We want them because the source code, in order to compile, needs to know what to effectively use, and it's the same thing as using this in the code generator. And then we're starting building a string builder for that. So we're writing this as if it is a text file that you're writing. And then we need the class name because we're going to use it for the new object. I think we're going to keep the name of the product, but the new class will be called product DTO. So this should look like mappable type declaration dot identifier to string, and this will give us the name of the class. And then we need to say that the generated class name equals class name at DTO. So this will be the name of the new class that we're going to make. And then basically what I want to do is I want to split the code to this point and then get the second half and then get the first half and write it. And I'm doing that because I want to be able to easily replace the name. There's other ways to do it by replacing the node, but it's quite harder. So I'm going to go the hacky way, and I'm just going to say var split class equals mappable type declaration dot to string, and I'm splitting on the first curly brace. And then it's a matter of applying the first bit, which is using statements, namespace, and all the way to class name. So basically all the way to here. So to do that, I'm going to use this, and I'm going to say gen class name here. So I built all the way to this line. So I need the rest, and the rest should be the second part. But in case there is another constructor that we need to change here, because I didn't use the constructor declaration syntax, I will do this instead, and I'm going to say append line and find the anything else referring to the old name and replace it with DTO. Now this is quite hacky because if you name something else product in the second part of the class, you will also rename it. So there's definitely better ways to go about it, but we're trying to prove the concept here. We're not trying to make the best elegant solution here. So we have that, and then the last thing you want to do is take that and go to the context, which is the thing at the top here, and add source, and we're going to give it a name. So I'm going to say mapper generator underscore gen class name here. And what's going here is the source code, source text from the source builder that goes here. Can you even see this? I think you can. And I'm also going to specify the encoding to be UTF-8, just to be sure. And with that, I'm going to stick a breakpoint here and debug this. So let's build this and pray that this works. So this goes here. Yep, hit the debugger. And I can now go forward and show you that we have the syntax trees. We have all of them. We're iterating over them. Oh, that's actually the controller one. That's not the one we want. Let's F5 here. Now it hits the one that we want. Cool. And now we're iterating over the syntax trees. We're looking for mappable declarations, nothing here. So we skip over, go to the next one. Mappable declarations, nothing. It should be the third one. Yep, here we go. Using statements, and we build the using bit at the top. So that's great. And then we're generating the source builder using that using statement. Then we get the class name and the gen class name. We create the split classes. We build the first part. Then we replace and set the second part, and we have the final code, which if I say to string, you will see here that it is a full DTO class that we will map to. And if I click go on, you know, it's built, which means I can go here now and say var product DTO equals new product DTO. And this class is 100% source generated. You can see it here, but it is under the mapper generator.cs that I talked about. And you can't really edit it directly. You have to mutate the source generator, which means that we can now do our mapping from the ID to the product ID. And again, you can actually even write the mapper itself, the thing that does this. You can do it through code generators, sorry, source generators. So that can even be done. It just takes more time. Now, another thing that you might want to do with this is to have an ignore attribute, right? Because sometimes you want to ignore a property. So what I'm going to do instead is I'm going to copy that. I'm going to say mappable ignore. I'm going to say method, so, or actually property, because we have properties. So now I can go to the property, the mappable object, and say mappable ignore. And I can go back to my mappable generator. And at this point, I can actually try to get all the mappable classes, all the properties in the mappable class that have this mappable ignore thing. And if I see it, then I remove it from the tree on the class that I'm generating. And getting it would look like this, something like this. You would have the ignore properties. In order to get them, let me just make this smaller. In order to get them, you would go through the child nodes of the mappable type declaration that you're working with, and then try to see the property declaration syntax, whether it's property declaration or not, get the attributes, and if it has the mappable ignore, which is this, then you have to remove it. And in order to remove it, all you need to do is mappable type declaration dot remove node, or actually we can even do nodes here and say ignored properties, comma, and I'm gonna say keep end of line here. But obviously this can't mutate the actual type declaration because you cannot really change the existing one. So we have to reassign it to a new mappable equals that. Yeah, this has to be capital M. Here we go. And now that we have that, that's what we're working here with. So replace that here instead of the mappable type, and that's what we're gonna end up writing, the new one. So split class, split in two places, we replace that, and what is missing is that, oh, actually nothing is missing, this will not be null, and now I can, let me just even disable the debugger because I don't think I need it. And if I refresh, it says that it does not contain a description, and this is happening because of this happening here. So if I disable this and I rebuild, it no longer happens. So I got a failure because code was using that property already. It is no longer there. And if you actually check the class, you'll see that it's no longer here. Oh, they added this, that's cool. So I can delete this, and we have the ignored property working as well. And I could take it even further. You could even say, okay, have a custom prefix here, for example, the mappable. Let me just quickly do that. So have something like this, suffix, and it's getter only, and then you have a constructor, and in the constructor you have string suffix equals empty, and you can just say suffix equals suffix. Here we go. And then if your mappable attribute has a different one, let's say Nick, then we pick this up and we append that to the new class instead of DTO. So if we want to do that, we'd go back to the mappable editor, and I'm not going to talk you through this code again. I'm going to show you how it would look like. We would first have to get the argument list for that mappable attribute, and then the suffix is here. So we have to calculate whether the suffix exists or not, and then determine whether we're going to use it or not. So this would look like this. So if it's white space or null, then don't use it, use the DTO. If it is not, then use that. And I would have to replace this with this here. And now it will also pick that up. So let's rebuild here and see what we have. Oh, DTO couldn't found. Oh yeah, that's because we're already referring to this new class that was deleted. So if I rebuild, here we go. Actually, I could just replace this with product Nick, and you will see that this now exists, and this now has the new suffix. So that's basically it. Maybe too much information to take in one sitting, but the way I'm thinking about it is that there's so many things you can do, not just mapping, but just the ability to have compile time, source generation. I think is amazing, because there are projects like Job, for example, that provide 7 times faster dependency injection resolution than the built-in DI container that Microsoft provides, just because compile time is faster. You don't lose anything on the testability, because all the replacements happen during compile time. So there's huge potential, and I kind of believe that Microsoft did this feature primarily for themselves, because they can optimize .NET so much by using it. Startup times will decrease because all the reflection bootstrapping that is happening will now happen in compile time and all that. And I highly recommend you take a look into this one, because it's a feature that it will only get bigger from here, and it's a very powerful one. That's all I had for you for this video. Thank you very much for watching. Special thanks to my Patreons for making this videos possible. If you want to support me as well, you're going to find the link in the description down below. Leave a like if you like this video, subscribe for more content like this, and ring the bell as well, and I'll see you in the next video. Keep coding.